called Made in Space. I'm going to give you a short little video of the project we're working on. It's called Argonaut. It is going to be flying in probably 2 years or so. I'm working on the central CPU processor that we're using a radiation hardened or radiation tolerant FPGA, and be probably putting a RISC-V core in it. So this is going to go up. It's going to 3D print a 30 meter beam, and as it's printing, it's unrolling solar film. So it's going to actually build the solar arrays in space. So we already have a 3D printer on the ISS. We were the first space-rated 3D printer. So it's on the ISS, and it prints tools and things like that for the astronauts. We have there's a couple dozen projects, everything from growing fiber optics in space. We're in zero gravity. The fiber optics would be so clear that you get way more data and a lot more range.
Real quick, is that multi-node or single-node fibers? Yes.
I don't know. I'm not a fiber guy. Yeah, that's a different group. But we're also working on growing crystals in space and quite a few other things. It's a pretty amazing company. So this is Argonaut 1, and you can see it's extruding the beam. So that arm right there, I'm working with the team that's going to be building and controlling that arm.
So this exists not inside the ISS, but...
This is space. Yeah, this is a spacecraft. Yeah. Yep. So I heard it's going to be about a year mission. It's a proof of concept, proving that we can build things in space. So you can see how it's extruding the solar panel structure, and it unfolds the solar film at the same time. It's a very cool project. We just got funded, and it was announced a couple of weeks ago, or maybe 3 or 4 weeks ago. So that's what I do for a living, and great place to work. So. Made in Space. We're at the NASA Ames Research Center in Moffett Field, and our main facility is in Jacksonville, Florida, and I think we have another facility in Luxembourg. We're doing a lot of work for NASA.
That solar film is solar material on a plastic base of some kind? It just rolls out or slides out?
Yeah, it's solar film, so it's on a roll. It's not very efficient. It's like the space material, I think, is 8 to 10% efficient, but of course it's super compact, and in space you have lots of room, so it's better to, the cost for getting stuff up there is really high, so if you can get it up there, you've got plenty of room. So this is okay, so let me give you the scoop on the boards. The boards are being fabricated and stuffed, which means assembled. I'm an old guy, stuffed. So I will get boards in probably 7 to 10 days. All the people that bought boards, I was thinking, instead of waiting for the next meeting, that maybe, depending on what everybody wants to do, we could either all get together, pick a Saturday, and I could deliver the boards to you, and maybe we could have a little workshop. Or if you wanted to come by Moffett Field, we can go to lunch or something, and you could pick up a board there if you want to get it before the next meeting. I did order 15 boards. The cost was right at $50 with the programming cable. I ordered some 6-foot USB programming cables as well. So,
Do you want the whole September meeting?
What's that?
Do you want the whole September meeting, or can you use the September meeting until the September meeting?
we probably should check the boards out first. So I think, I don't know. We should talk about it. If maybe if we don't do September, maybe we do October. I'm sure we'd have a lot of stuff to show in October.
What are these boards?
Okay, so I developed a robot, intelligent control board for robotics back in '91, and it used Maxforth, and I developed a 3-tiered artificial intelligence operating system language for intelligent machines, for mobile robots in particular. And it has 3 levels. It has the instinct level, where you have motor sensor fusion at that level. Whiskers had 2 forward-looking optical sensors, could see about 6 to 12 inches away. 2 side-looking, 2 Whiskers, where he gets his name from. He had a speaker and also a microphone so he could hear. I also monitored the current in each one of the, there's 2 motors, differentially steered. I monitored the current in each motor, so even if something hit the chassis and a sensor didn't see it, that was a sensor of last resort. So how do you manage all these sensors in an intelligent way? Can you imagine building, a big case statement, or a loop, and a bunch of if-then statements? It'd be very messy to do this. So I was looking at something. I wanted to design an operating system that was real-time and very deterministic in its behaviors. So back in 1989, I was getting on the Interocitor bulletin board, because that was before the internet, and I was monitoring comp.robotics. So Marvin Minsky and Hans Moravec, Minsky's from MIT, Moravec's from Carnegie Mellon, were saying we need 10 terahertz processors to solve the problem of navigating across this room. And they built a robot called Shakey, I think it was. And they had vision, and the thing would go like a foot, and it would stop and think and find out, remap the room. Their whole thing was mapping, so it's top down. Rodney Brooks, co-founder of iRobot, he was getting his PhD at MIT, and he's sitting in his office. He's watching a fly around. Flies are great at collision avoidance, but they only have 1,500 neurons. How does a fly do that? Well, it's just motor sensor fusion. They have no brains, but they're really good at collision avoidance. So he came up with what's called subsumption architecture, that basically you have layers, and each layer subsumes control from the other one. The problem with his is you couldn't give it a goal. So it could randomly do collision avoidance really well. So I thought, what we really need is to marry the 2 ideas together. And I came up with a 2-level architecture. So we are all programmers in this room. So the main loop is the goal level. And then I used an ISR to create the background, the instinct level. Well, what happens if you have 2 cups and the robot comes and this whisker touches the left cup and then it touches the right? It'll sit there and oscillate because it's not thinking, it's just reacting. So how do you arbitrate that? You could have the main loop go and do this massive case statement, seeing what sensors are triggered. I want to get away from that. So what I decided to do was to create a task processor. I call it the behavior level. And now you make simple if these sensors, if you have this sensor pattern, then do this stuff. Now, between the goal level and the behavior level is cooperative. So, which means when the behavior takes control, whatever the goal level was doing ceases until the behavior returns control again. Between the instinct level and the behavior and the goal level is is preemptive multitasking. So instinct level is always running. But there is flags that the upper levels can control the instinct level and turn things on and off and stuff like that. So I created this, when I added the third level, the behaviors, now the machine, you could program it to cross the room with just the instincts and behaviors, and the goal level, you don't even need it. So the goal level, you would use it like with a vision system, say, or sonar, to find the door. And the goal level is just, the door's at 260 degrees. The door's at, 250 degrees. And hold that compass heading. I had a behavior called compass that would automatically adjust the wheel speeds, the differential steering, so that it would follow a certain heading. So I was at a trade show, and I was explaining this to someone, and the lady was a biologist. She said, that's the triune brain. And I said, what's that? Well, it turns out I was solving an engineering problem, and I actually emulated nature. I emulated the way that we work and the way animals work. So I started calling it the Triune OS. So I sold about 2,000 robots into the education market. I also built the first man-packable robot for the US military before iRobot's PackBot. I knew Helen Granier. She was president of iRobot at the time. In fact, she actually wanted to hire me at one point, and I was stupid, and because I was starting my own company, and yeah, I should have taken it, but I had to move to Boston. But anyway, so what these boards are is basically the next generation. So I did that in '91. They were all through-hole components, using a 68C11 8-bit microprocessor running at 8 megahertz. I was probably using 10% of the bandwidth of the processor, my Triune OS, because it doesn't need to do a lot of processing once you break it apart into the 3 levels. So the new board is using the ESP32, which has 400K of RAM. I don't know what we're going to do with all that memory. It's a true 32-bit machine, but it also has Wi-Fi and Bluetooth. So Dr. Ting has been working, and was it Brad? Yeah, has been working on the Wi-Fi part of it, and they got it working. So you're going to be able to talk to this little robot that runs around your house using your laptop. And you'll be able to program it. It's going to be running forth. You're going to be able to use the Arduino IDE. You're going to have access to the C stuff as well. You're going to be able to marry the two together, right? Tell me if I'm wrong. So these boards are, I'm just doing this because I want to get it out to the community. It's going to be open hardware, open software. We're taking the original Whiskers code and porting it over to this new processor, and all the source code will be made available, and design files. So if you want to go build your own robots, start a company. I don't care. So the cost of these boards is $50, and that's what my cost is. I'm not marking it up. So we have 8 boards. 7 people in the group have bought 8 of these boards. I'm making 15. So we will have 7 available, and I'm going to donate a couple to the group. We can use it for promoting our group and everything. So let me just talk about Forth and C. I program professionally in C, but if you want to build an intelligent machine, Forth is way better. I've programmed both. C is a programming language. Forth is, it's an operating system. It's a programming language. It has incremental compilation. It's interpretive, but it runs as fast as C. We're going to be building, many people in this group are very interested in AI. We're going to be doing a lot of AI work on this board. One of the guys is going to put an expert system on it. We have a lot, and that's my interest too, is AI. I don't want to build another stupid robot that runs around and, does collision avoidance. So, because we can access the internet, IBM allows you to use Watson for free. Our robot, you could ask our robot some question about something, and it could go to the internet. It could go query Watson. There's several other free AI kind of things on the internet that our robot could actually access. So it's going to be a really smart robot because the entire internet will be at its disposal, and it's going to be running for it. So that's what we're doing. So this morning, I finished up the board design, and they're getting built. So obviously the next thing is, what do you put it on? Because $50 is just the board. So this morning, I started. I love Windows. I started thinking about the platform, and I came up with some ideas I'd like to go over with the group here. Oh, come on. Windows 10 is always advertising. So we have, on the machine, we have a true electronic compass. It's actually a 3D chip, so it has acceleration and inclination. We also have an SD card, so you can have up to 128 gigs of flash memory on it if you want it. It's going to have 2 Whiskers. It's going to have the same LEDs as my original Whiskers robot. There's 2 side-looking ones. It's differentially steered. These are the motors. So I found on AliExpress, I found a motor with a bracket and everything assembled for a very reasonable price. I ordered some samples. We have a speaker port, which Dr. Ting has singing and dancing. What were you doing, Bach or something on it, weren't you? We also have a microphone. We have this 32-bit processor, so you're going to be able to digitize sound, ambient sound, and do things with it. What's new to this robot is we also have sonar, piezoelectric sonar sensors. So you'd be able to take the robot and just do a scan of the room and find the path. We have a USB cable for hooking it up to Arduino IDE, so you can do programming and software development. My target is to try to get this kit right around $50. I can't guarantee that just yet, but it's kind of looking promising. There'll be some 3D printing involved. So that's the kind of the basic machine. It's probably going to be somewhere around like that big. So it's a development platform, and it's for people to get familiar with my Triune OS and develop it further with the idea of building intelligent machines. So, any thoughts on mechanical? It's trying to keep it pretty simple. So this is a circuit board, and I thought, it's educational, so we won't put a case around it. It's nice to see the circuit board. Maybe we put a piece of plexiglass over it, for kids, but you guys don't need it. So basically, there'll be a plate, and then these 2 things will be 3D printed. No, it's differentially steered, so I got a side view. Yeah, so it has a rear caster. You can get those at Home Depot. They're the big ball kind of ones where it goes in any direction. So I actually played around with them back in the early days. I On Whiskers, I used a regular offset caster, but on this one, I'm going to use the ball. If you're going, in the dirt a lot, you probably should use the other one. But I don't think we'll be, mostly for the house. So it's differentially steered. The bigger wheels are actually very good because when you think about going from a hard floor to carpeting, the bigger the wheel, it just makes it easier for it to climb over it. So, this robot could climb over maybe an inch tall, like a book or something. So we'd like to really kind of use this to get forth out there again.
And this could be sold after this quarter as well. Like we can have another batch or have them made on demand and assembled as a fab or something like that. So we don't have to assemble them all themselves afterwards.
The boards?
Yeah, the robot will be available after this this batch.
Yeah, so the first batch of robots, I'm building 15 of everything. We already have 8 of them, 8 of them sold in the group. And we can continue on. I'm not stopping at 15. If we use up all 15, we can do another batch.
Some fabs have they will assemble everything for you as well.
That's what I'm having done. The first boards I got, I just got the boards. I didn't have them assembled. Because I was just going to, do some hand soldering, but I don't have time for it. I got to just have it done. It's too time consuming.
Costs a little bit more, but
Yeah. So for 15, it's like $750. So it's turns out to be $46, but then the programming cable's another $2, so it's $48. So it's not worth my time to try to assemble them.
they're assembled by the fab and sort of managed itself.
Yeah. Yeah, so to answer your question, we'll be able to order more as we need them.
Is there a web page or something like this?
I use PCB Wait. Are you talking about the fab house?
Like a web page that I could link people to for this.
Yeah, I haven't set it up yet. I plan on setting that up, and if anybody wants to volunteer, go for it. I was kind of thinking, we should have some stuff working because, people aren't going to get involved until they see it work,
Example project.
Right. But I think in a few months that absolutely we'll have a web page. This robot I know would be a big hit in education. The poor kids, a teenager with 0 programming experience would take a Whiskers. In 10 hours, they would be doing do loops. They learned about if-then else statements. They learned the basics of programming with a really fun robot. And Whiskers gets mad. One of his behaviors I put in him is called frustration. And so if you keep putting your hands around his sensors, he keeps trying to get away, and all of a sudden he gets pissed, and he starts rocking back and forth and going, woo, woo, woo. And the kids just love that. It's very anthropomorphic, it's very animalistic. And, they don't, and they usually named Whiskers too. They'd have, names for it because it's very animal-like. I was trying to build, like a cat, a cat or a dog, kind of intelligence. That was my goal. What's that? Yeah, well, dogs. Dogs are more intelligent than cats, obviously. Whiskers was as smart as a cat, for sure. Wasn't as smart as a dog. So,
Cats are smarter than dogs.
yeah.
You can't domesticate cats.
Exactly, yeah. Whiskers was really as smart as a cat. I mean, what does a cat do? Lie down and eat and purrs when you pet it.
I think, we saw that a number of
Right.
They took in projects. So if you have a good design, you just take it and then the manufacturer. And it's amazing that for $50 a kit, how many things you can get.
Yep, it is. But to make an intelligent robot, it's you people in this room. This is the center. I mean, you guys know Forth like inside and out. So let's build a really intelligent robot. Forth is the best, bar none, language for robotics. And if we can use this as a Trojan horse, a technology Trojan horse, and get it out there and show show people how smart a robot can really be. Roombas are so stupid; it's just amazing. They've sold $1 billion worth of them. Funny story about that. So I designed Whiskers. I started selling them, and right around '93, '94, I was looking at Whiskers and I was going, I wish I could do I wish it would do something besides just be a platform for my my Triune OS. So I was in AutoZone and they had this little vacuum cleaner made by Black & Decker. You plug it into 12-volt lighter, about this tall, about this big, for doing your seats. So I go, hey, I could hook that up to the tail of Whiskers, and Whiskers is 12 volts, so it's got the power. So I went back and I hooked it up and I let it run around, and Whiskers couldn't see. This robot can see far, but and this robot has a electronic compass where Whiskers didn't. I actually made a virtual compass from the pulse width modulation, counting the pulse width modulation on time. I made a crude compass because I found it was really important for navigation. And anyway, so I hooked it up and I let it run around, and of course it was just randomly running around, hauling this vacuum cleaner around, and I go, nobody'd ever buy that. That was '94. Roomba came out 10 years later, or 15. Yeah. You just never know, what's going to sell. So that's what we're doing. Any thoughts on the mechanical side of things that you want me to consider?
Just when we think about the style envelope, we keep the envelope R2D2. Yeah.
Well, one of the things, this robot's going to have a lot of personality. Now, one of the personalities that I really love is R2D2. So with this robot, we can very easily emulate the way R2D2 communicates, right? I don't like cute robots. I like robots that look like robots. So, I would never kind of make it in they make all these cute type ones. I like a robot that has an industrial, practical look to it. And I think to me, that's sexy. Like having the circuit board where you can see it instead of hiding in a box. Actually, Whisker, I had it on the top and I had a clear plex formed on the top. So this one we put, if we're going to sell it to the public, we'll put a piece of plex over it. But, seeing what makes it tick is fun. Yeah. So it's a fairly simple, straightforward design. It'll be, very low cost to manufacture. And we can start with this and you can build your own. You can buy the board. You got an idea for your own base, you can buy the parts, some parts from me, or you can buy the whole kit. I don't care. I'll tell you, where I buy the parts, and you can go buy it yourself. Whatever.
You mentioned a CPU that you're putting on FPGA. I recently read that RTX ports is hardware class IP for FPGAs.
Yeah, I'm familiar with the RTX. I got them looking at the RISC-V. I've been promoting that. What I like about the RISC-V is RISC has been around for 20 years, and you know, as we as we develop technology, and we start having a rear view mirror and we see what worked and what didn't. You know, people took a fresh look at RISC when they made the RISC-V, and it's completely open. There's no royalties, no fees whatsoever. There's a RISC-V Foundation. And you know, my company programs in C++ and C. So, you know, the RTX is a fourth machine. Yeah, so it makes, for made in space, it makes sense to use the RISC. All right, that's it for me.
You want to do, who's coming to dinner? Okay, who's coming to dinner?
Okay.
I'll go.